Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter Aldehydes, Ketones and Carboxylic acids. Aldehydes, Ketones and Carboxylic acids. Carbonyl compounds are of almost importance to organic chemistry. They are constituent of fabrics, flavorings, plastics and drugs. I have discussed organic compounds with functional groups containing carbon-oxygen single bond. Now here I am going to discuss organic compounds containing carbon-oxygen double bond called carbonyl group, which is one of the most important functional group in organic chemistry. In aldehydes, the carbonyl group is bonded to a carbon and hydrogen, while in ketones it is bonded to two carbon atoms. Here important point you should note down. In aldehydes, the carbonyl group is bonded to a carbon and hydrogen. It is bonded to a carbon and hydrogen. This is an important point. In aldehyde, the carbonyl group is bonded to a carbon and hydrogen, while in the ketones, it is bonded to two carbon atoms. The carbonyl compounds in which carbonyl group is bonded to oxygen are known as carboxylic acid. Again you listen, the carbonyl compounds in which carbonyl group is bonded to a oxygen are known as carboxylic acids and their derivatives, as for example esters, anhydrides, while in compounds where carbon is attached to nitrogen and two halogens are called amides and acyl halides respectively. The general formula of these classes of compounds, now I will give examples. Okay, general formulas of these classes of compounds are now I am telling you. First is aldehyde. Here carbonyl compound means CO that is attached with R and H. Then this COH, or you can tell CHO. This is the aldehyde group. R is attached with carbon. Alkyl group is attached with carbon, means carbonyl group. Here R is attached to carbonyl group, and that carbon means with carbonyl carbon hydrogen is attached. That's why this COH or CHO, anyway you can tell, that is called aldehyde. Now second example, that is with carbonyl carbon, now two alkyl group is attached, RCOR, means CO is in the middle, C and O, double bond is there, always double bond, carbon and oxygen double bond. Then in aldehyde you have seen one with this carbon of carbonyl compound, carbonyl group, one side R is attached, other side H is attached. Then this COH is aldehyde, But here now with carbonyl carbon, both side alkyl group is attached. One side R, other side R dash. One side R, other side R dash, means different alkyl groups. Then this is the example of ketone, RCOR. RCOR, this is the example of ketone, or formula you can tell, general formula. RCHO, then CHO is aldehyde, and here RCOR, that is the ketone. Now for carboxylic acid, now I am telling you, here carbonyl compound group, from the carbonyl group, from that carbon one side R is attached, other side OH is attached. In here in with carbonyl carbon, one side R is attached, other side OH is attached. CO is in the middle. Then this is the example, or you can tell general formula of carboxylic acid, means RCOOH. RCOOH. C is in the middle with attached with oxygen with a double bond, and that carbon is attached with OH, one side from R, other side from OH. Then now it is called RCOOH. This is the general formula of carboxylic acid. Now this RCOX, carbonyl group, is in the middle, CO. One side it is attached with R, and other side it is attached with X. Then this is the general formula of acyl halide, RCOX. COX actually is the acyl halide, where X is halogen. And now I am telling about acid anhydride. Oxygen is in the middle. Or you can understand like that two carbonyl group means CO and CO. Just consider two CO. Then with one CO R is attached, and with other CO R dash is attached. With one CO R is attached, and with other CO R dash is attached. And now both carbon of CO that is attached with oxygen. Both C is attached to itself through oxygen, means oxygen is in the middle. RCO left side, and other side in the middle is oxygen. Then left side RCO, right side also RCO. R may be same or different, R dash. Then RCO O, again RCO O. Correct? Both RCO is attached through oxygen in the middle. Then this is the general formula of acid anhydride. This is the anhydride, acid anhydride, means RCO, again O, and again COR. RCO in the after that O, and after that again COR. Means RCO is in both sides of oxygen. Okay, RCO in the middle oxygen, again RCO, means both carbon is attached with oxygen. This is the general formula of acid anhydride. Now ester formula I am telling you. Ester formula. Here again with carbonyl, carbonyl group, carbon of carbonyl group. With carbon of carbonyl group means CO. One side R is attached and other side OR is attached. OR dash you can tell. OR dash. R and R dash means both group may or may be different, same or different. Then now R C double bond O, and again with C OR is attached, means you can tell R C double O R dash. This is a general formula of ester. R C double O R dash. This is the formula, general formula of ester. Now amide, you can see amide. Now with carbon of carbonyl group, one side R is there and other side NH2. With carbonyl group, it is attached one side by R, means alkyl, and other side it is attached with NH2. Then this is the general formula of amide, RCONH2. Remember amide formula, general formula RCONH2. Aldehyde, ketones and carboxylic acids are widespread in plants and animal kingdom. This is an important point. Aldehydes, ketones and carboxylic acids are widespread in plants and animal kingdom. They play an important role in biochemical process of life. They add fragrance and flavor to nature. For example, vanillin from vanilla beans, salicylaldehyde from meadow sweet, salicylaldehyde from meadow sweet, and cinnamaldehyde from cinnamon have very pleasant fragrance. Again, example I am telling you because questions are asked in general competition also, engineering also, medical also. Again, I am telling you these aldehyde, ketones and carboxylic acids are widespread in plants and animal kingdom. They play an important role in biochemical process of life. They add fragrance and flavor to nature. What are the examples? Then vanillin from vanilla beans, salicylaldehyde from meadow sweet, and cinnamaldehyde from cinnamon have very pleasant fragrances. Now, what is the structure of vanillin? Vanillin structure, very important things I am telling you now. Question is asked. Then vanillin means here with benzene ring. With benzene ring, 3 groups are attached. 3 groups are attached. Means at carbon number 1, aldehyde group is attached. And at carbon number 3, OCH3 is attached. And carbon number 4, OH group is attached. Three groups are there. Aldehyde group, CHO, carbon number 1. And OCH3 group, that is a carbon number 3. And OH group, carbon number 4. This is the structure of vanillin. And what is the structure of salicylaldehyde? Already I have discussed. Again I am telling you. One group is aldehyde at carbon number 1 and OH group at carbon number 2. This is the salicylaldehyde. And like that way, cinnamaldehyde is a little uncommon for you people. at lower standards. Actually, you will study it in details in BSc onward. Okay, but here I am telling you cinnamaldehyde, that from the benzene ring, CH double bond CH, CHO is attached. Means 3 carbon, group of 3 carbon is attached. CH double bond, and that CH is attached with CHO. Okay, means just like you can understand alkene group, alkenes, carbon double bond. From the alkene, one CHO group is attached, and that group CHO is attached with benzene. Then now with carbon only CH is remaining. Alkene, CH2 is know that it is alkene, but from the both carbon, one hydrogen is, you can say, that replaced, that from each carbon of alkene, now one hydrogen that is replaced with benzene, and from the other carbon hydrogen, one hydrogen that is replaced by CHO group. Means in ethylene, one side benzene is attached and other side CHO is attached. Then it is called cinnamaldehyde. I think it is, you will remember easily that in alkene group, 2 hydrogen was there, CH2, then one hydrogen is replaced with benzene, and other carbon, one hydrogen is replaced with aldehyde. Then you will get with this structure of cinnamaldehyde. Now, what are the uses of these compounds? Then they are used in many food products and pharmaceuticals to add flavors. Some of these families are manufactured for use as solvents, that is the acetone, and for preparing materials like adhesive, paints, resins, perfumes, plastics, fabrics, etc. Now I am going to discuss about structure of carbonyl group. Structure of carbonyl group. Then first I will discuss about aldehyde and ketone. Aldehyde and ketones. Aldehyde and ketones are the simplest and most important carbonyl compounds. They are two systems of, actually there are two systems of nomenclature of aldehyde and ketones. Okay, nomenclature also I will tell you. Nomenclature. Then there are two systems of nomenclature of aldehyde and ketone. Aldehyde, I already discussed, it's a structure that is the CHO group, C double bond O, and that C is attached with one side with R, other side with H. When CO group is attached, carbon of CO group is attached with H, then this is called aldehyde group, CHO, and other side may attached with alkyl R. And ketone, C double bond O, and one side R, other side R dash. Then this CO group is common in aldehyde and ketone. Okay, but RCOR, C double bond O, next side R dash. Then RC double bond O, and right side R dash, left side R, other side R dash. That is the ketone. Okay. Then simple example of ketone is if both sides CH3 is attached, then it is called acetone. But CO is ketonic group, and COH, that is aldehyde group. Now just come to the name nomenclature. Then first, just to understand common names. Aldehyde and ketones are called by their common names instead of IUPAC names. The common names of most aldehyde are derived from the common names of corresponding carboxylic acid by replacing the ending "ic" of acid with aldehyde. Again you listen, by replacing the ending "ic" ending "ic" of acid with aldehyde. At the same time, the names affect the Latin or Greek term for the original source of acid or aldehyde. The location of the substituent in the carbon chain is indicated by Greek letters alpha, beta, gamma, delta, etc. The alpha carbon being the one directly linked to the aldehyde group, beta carbon the next, and so on. Okay, then CH3CHO, example I am telling you, CH3CHO. Now in the place of R, CH3 is attached with aldehyde group, CHO group. Then it is called acetaldehyde. Acetaldehyde. Okay. Aldehyde group is acetic acid was then acetic. Then IC removed and aldehyde joined. That's why it is called acetaldehyde. Acetic acid is there, acetic acid, then that acetic, IC removed and aldehyde is attached. That's why CH3CHO is called acetaldehyde. Okay, acid plus aldehyde, acetaldehyde. Like that way, from benzene, aldehyde group is attached. If from benzene, aldehyde group is attached, then it is called benzaldehyde. Benzene, that from benzene. Now, benz is there, En is removed. Okay, benzaldehyde. Benzaldehyde means with from benzene, CHO is attached, it is called benzaldehyde. Now, this example you can see for alpha, beta, gamma, delta. Then now suppose this 3 carbons are there, CH3, CHBr, CH2, and with CH2 suppose CHO group is attached, means aldehyde group is attached with you can say propane. With propane means 3 carbon, from that CHO is attached. Then how will you give numbering? How will you tell which one is alpha, which one is beta, which one is gamma? How will you tell which one is delta? Delta will come when you will take the butane. If from the butane aldehyde group is attached, then delta also will come. But here propane is there, and it's alpha, beta, gamma only 3 position, 3 locant will come. Then with this carbon to which aldehyde group is attached, that is called alpha. The carbon to which CHO group is attached, means aldehyde group is attached, that carbon is called alpha. And next to alpha, beta, and next to beta, gamma. If 4 are there, then next to gamma, delta. Okay. Then now suppose at carbon number you can tell our beta position, alpha, beta, gamma. Then now from the aldehyde carbon, first is the CH2, that is the alpha, and next to this CH2 bromine atom is attached. That is at beta carbon bromine is attached. Correct? That is the CHBr. And next to this carbon, that will be gamma. Hence its nomenclature will be beta bromo, because at bromo carbon beta bromine is attached. That's why beta bromo. And total carbon including carbon of CHO, it is becoming 4 total. Then beta bromo butyl aldehyde. Beta carbon number at beta position, bromine is there. That's why beta bromo. And here that is the BUTY, butyl aldehyde, 2 letter of this butane you have removed. Then now it became beta bromo butyl BUTYR, BUTYR, butyl aldehyde. Okay. Then I have given some examples of common name of aldehyde. Now the common names of acetone are derived by the naming two alkyl or aryl groups bonded to the carbonyl group. The locations of substituents are indicated by Greek letter alpha, alpha dash, beta, beta dash, and so on, by beginning with the carbon atom next to the carbonyl group indicated by alpha, alpha. Some ketones have historical common names. The simplest dimethyl ketone is called acetone. Dimethyl ketone is called acetone. Already I have told you. Alkyl phenyl ketones. One side alkyl, CO group is there. Then one side alkyl group, other side phenyl group. Then it is called alkyl phenyl ketone. Are usually named by adding the acyl group as prefix to phenone. For example, first I understand acetone, CO is there, C double bond O, C and O double bond is there, C and oxygen, carbon oxygen double bond, one side CH3, other side also CH3, same. Then it is the example of acetone, it is called acetone, and CO group is called ketone. If both sides same group is attached, CH3, then it is called acetone. Now here you can see acetophenone, CO is there, one side benzene is there, other side methyl group is attached. That's why name is a acetophenone, aceto due to the CH3, and acetophenone, then PHE is due to phenyl group, benzene ring. Hence this is called acetophenone. And like same way, if you can say this CH3, CH2, CO, or you can tell with CO one side phenyl is there and the other side ethyl group is attached. One side benzene ring is attached and other side ethyl group is attached. Then it is called propiophenone, propio because of propane. Total including carbon of CO, carbonyl carbon including this C2H5 is there, means CH2, CH3. Then total is the 3. Then it is propane. Then one side just like a propane, other side phenyl, means benzene. Then it will called that is the propiophenone. Propio means prop word came from the propane, propio. Okay. and phenone is due to the benzene. Now if both side benzene is attached, CO is in the middle, carbonyl group is there in the middle, one side benzene, other side also benzene, then that is called benzophenone. Benzophenone, just like a ketone, it is called benzophenone. Okay. Now just to come to the these things, IUPAC names. IUPAC name. Then I will give examples, but what are the rules I will tell you. This is very, very important. The IUPAC names of open chain aliphatic aldehyde and ketones are derived from the names of the corresponding alkanes by replacing ending E with Al. Replacing the ending E with Al in case of aldehyde and ONE. Okay. Again I am telling you, the IUPAC names of open chain aliphatic aldehyde and ketones are derived from the names of the corresponding alkanes by replacing the ending E with Al and ONE respectively. Means E you have to remove, and you have to add Al. Shortcut name aldehyde. For aldehyde it is Al, and after removing E, if you add ONE, then it will be called Al and ON. Okay, means it just like ethanol. Okay, pentanol, and for if you will remove E and ONE you will add, then it will become, you can say, just like a pentone, ONE. Okay, then this you understand, E is removed and in the place of E, Al is added in case of aldehyde, and ONE is added in case of ketone. In case of aldehyde, the longest carbon chain is numbered starting from the carbon of the aldehyde group. It is an important point. In case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in case of ketones, the numbering begins from the end nearer to the carbonyl group. The substituents are prefixed in alphabetical order along with numerals indicating their position in the carbon chain. The same applies to cyclic ketones, where the carbonyl carbon is numbered 1. Carbonyl carbon is numbered 1. When the aldehyde group is attached to a ring, the suffix carbaldehyde is added after the full name of the cycloalkane. The numbering of the ring carbon atoms start from the carbon atom attached to the aldehyde group. The name of the simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is benzyl carbaldehyde. You remember it. This is very, very important. The name of the simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is benzene carbaldehyde. However, the common name benzaldehyde is also accepted by IUPAC. Other aromatic aldehydes are hence named as substituted benzaldehyde. Okay. Now examples I am telling you. That is the CH3 is attached with CHO group. If CH3 is attached with CHO group, then total carbon is 2. CH3 is attached with COH, means with carbonyl carbon. Then total carbon is 2. That's why it is called ethanol. Ethanol, because aldehyde group is there. Then for that it is called ethanol. Ethane was there, then E has been removed. Ethane, A-N-E. The letter E is removed and Al is add, ethanol. Like that way you can say this. Now other example is that 1, 2, 3, 4, 5, 6. 6 carbon chain is attached with acetaldehyde group. This 5 carbon chain, 1, 2, 3, 4, 5, 6. 6 carbon chain is attached with aldehyde group. Means including aldehyde, carbon, it will be 7. It will be 7. Then 6 group is attached with aldehyde carbon. And at carbon number 3 and 4. Now I told you numbering will start from the carbon nearest to the CHO or attached to the CHO. Then first CH2, that carbon will get 1. Next 2. And after that 3. And after that, like again CH2, CH3 is there. Then here carbon number 4, in just call this starting from carbon of aldehyde. Start from that carbon, aldehyde carbon, that is the 1. Then next is 2, after that 3, after that 4. Then after that 3 are there. Then now that what will be the name? Then at carbon number 4, bromine is there. Then that's why it is called 4-bromo. And before bromine, means at carbon number 3, methyl group is attached. That's why it is called 3-methyl. Then now total 7 is left. Then total is 7. Okay, if we will remove this CHO group, then will be 7. Then here methyl group is also attached. You remember that is attached with carbon number 3, and carbon number 4 is bromo. Then 4-bromo, 3-methyl, heptane, E you remove, and Al you add, heptanol. Okay, because in total carbon including CHO carbon, including that it is 7. That means heptane. That E you removed and Al you add. Hence name will be 4-bromo 3-methyl heptanol. Now come to the example of one, ketone. Then here now just 5-membered ring you consider, means pentane. Then now that in that ring 1 CO group is attached. From 1 carbon oxygen is attached, oxygen double bond, means ketonic group is attached. In benzene ketonic group is there. Simply remember 5-membered ring is there, 5 carbon member, 5 carbon ring is there. a 5-membered carbon ring. From that, oxygen is attached with double bond, means CO, and one methyl group is attached. One methyl group is attached with this ring. With this ring, methyl group is attached. Then what will be the nomenclature? Then from the CO, from that carbon, third carbon is methyl group is developed. From that third carbon, methyl group is attached. Then what will be the nomenclature? 3-methyl. We will start with substituent. 3-methyl. After that is the ring is there. That's why we will use the word cyclo. And it is a pentane. Then now E letter you have to remove and you have to add on. Then 3-methyl cyclopentane on. Pentane is there, only E you have to remove and ONE you have to add. And 3-methyl cyclopentane on. Pentane on. Better you just spell dividing. Then you will spell correctly. 3-methyl cyclopentane on. Okay. Now next example I am telling you of benzaldehyde again, that with benzene ring CHO is attached. With benzene ring CHO is attached. Then already I told you, so it is not benzene, cyclohexane you can tell. Cyclohexane, because no double bond is there, all are single bond. Then cyclohexane. Then what will be the nomenclature? Then cyclohexane. Full name here you have to write. Cyclohexane. Carb aldehyde, because you are adding carb. That's why E you are not removing. Whenever benzene term will come, then write complete benzene like that way. Here cyclohexane you are writing, and carb word you are adding carb, 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 and then aldehyde you are writing, means cyclohexane carb aldehyde. Now another example I am telling you, that now suppose CH2CH2 means alkene was there, and with alkene first carbon ethyl group is attached, and with second carbon aldehyde group is attached. Alkene is there, double bond, then one hydrogen from both carbon is removed, and in its place one side ethyl group came, other side aldehyde is attached. Then total number of carbon will be, how many carbon will be there? Then 7 in this case you will be that this alkene is 2 carbon, 1 from and CHO 1 carbon 3, and this side 2. Okay. Then total will be 5 carbon. One side 2 carbon, other side CHO group is attached with alkene, means 2 carbon is in alkene. Then other side ethyl group is attached, means 2 carbon. Then 2 plus 2, 4 carbon. And right side CHO group is attached, means 1 carbon. Total 5. Then what will be the name? Then total carbon is 5. And double bond is there with carbon number 2, because CHO, that carbon C of CHO, numbering will start from the group carbon, means aldehyde group carbon. From that it will start. Then second carbon double bond is there between second and third. Then total 5 carbon is there, including carbon of CHO. Then it will be pent 2 in Al. Pentane, for that you are adding pent. Carbon number 2 double bond is there. That's why 2 in, in. and the end aldehyde is, for aldehyde you are writing Al, al, hence pent 2 in al, okay, pent 2 in al, 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 pent 2 in al. Now one more example I want to tell you for the ketone. Ketonic group is there, one side benzene is attached and other side ethyl group is attached. Then numbering you will start from the CO group, that C will become 1, CO, that carbon will be 1, okay. Then now you can tell 1 phenyl, because that from that CO group that carbon phenyl group is attached. Then 1 phenyl, after that ethyl is attached. Then including carbon of CO, that will be propane, 3 carbon means propane, and naming will be 3 phenyl propane, 1 one, because carbon number 1 ketonic group is there, CO group is there at carbon number 1, CO only from there numbering started, hence name will be 1 phenyl propane 1 one, okay, 1 one. Then this I have given example of, you can say IUPAC name, examples of IUPAC name. Like that way many examples are there. Now suppose if suppose 2 CO group is there in the same compound, 2 CO group is attached, then how will you expel? Then now suppose numbering and the end CHO group is attached. Now in this compound one ketonic group is there and other aldehyde group is there. 2 groups are there, one aldehyde group and one ketonic group, only in the same compound, 2 group, one aldehyde group, another ketonic group means CO. Then how will you do nomenclature? Then now you will start from the aldehyde carbon. From aldehyde carbon numbering will be there. Then carbon number third CO group is there, or you can tell that with CO group, one side ethyl group is attached. One side ethyl group is attached and other side CH2COH. CH2COH is attached, means actually it was CH3, acetaldehyde was there, CH3CHO. Then from that CH3 one H removed, and after that it has joined with other CO group, means CH3CH2, that is ethyl. After that CO is there, and that CO is attached with CH2, CH2, and that CH2 is attached with aldehyde, okay, means with CO group one side ethyl and other side CH2COH is attached. Then its naming will be what? Because numbering will start from the aldehyde carbon, then carbon number third CO group is coming, CO at carbon 3, then it will be 3-oxo, OXO, 3-oxo pentanal, because total number of carbon is 5. Then pentan, E you have removed, Al you have added, and if both are present, then that time oxo, you will, that CO group will be spelled as oxo, then 3-oxo pentanal. Now suppose with CO group both side now this same group is attached, okay. Then how will you spell? Means if what is attached, then CH3CH, and other side also CH3CH, but from the CH methyl group is attached both side, means CH3CH CH3 CH3 CH CH3 left side and CH3 CH CH3 same group which is attached with CO, left side same, right side also same. What are the group? Then again you just understand CH3, actually it was the propane, CH3 CH2 CH3 CH3 CH2 CH3, but one H removed and it joined with CO carbon. Same way other side propane was there, that in middle CH2 one H removed, and after that it joined with CO is in the middle. Then both sides same group. Then what will be the nomenclature? Then I told you nomenclature numbering will start from the CO carbon, CO from that carbon. Then carbon number 2 and carbon number 4. Carbon number 2 and carbon number 4, 2,4. Dimethyl. It will start from the this numbering will start, then carbon number 2 and carbon number 4. Carbon number 2 and carbon number 4, methyl group is there. That's why name will be 2,4. 2,4 dimethyl pentane. E you remove and 3 O, because actually when this is both sides same group is there, then numbering will come from any one end. Then here carbon number 2 and carbon number 4 methyl group is there. In the middle CO is there, that is coming actually at carbon number 3. Carbon number 3, that C and O double bond is there. Then name will be 2,4 dimethyl pentane. Carbon number 3 double bond is there, that's why it is called 3-on. But this double bond is between carbon and oxygen, CO group. Correct? Carboxyl group. Now this one more example I am telling you, that if from benzene NO2 group is attached, benzene group, two groups are there attached. One is aldehyde, other is NO2. NO2 is at para position or fourth position you can tell. Then what will be the name? 4-nitrobenzene. 4-nitrobenzene carbaldehyde, because if with benzene aldehyde group is attached, that is called benzene carbaldehyde. But here at carbon number 4, NO2 is attached. That's why we will tell 4-nitrobenzene carbaldehyde, or you can tell 4-nitrobenzaldehyde. Okay, and this last example I want to tell you, in that two aldehyde group is attached. Two aldehyde group is attached. CHO 2 times came in the only in the one molecule, one compound. Then what will be the name? Do not, you can tell three are there, total 3 are there, one mode. 3 aldehyde is attached. Then what will you do in the same molecule? Then here what you will how will understand? It is very easy to understand. Just you consider propane. Propane you consider, and from the each carbon one hydrogen removed, and in its place CHO group is attached. I think now it is clear. Propane, 3 carbon is there. From these 3 carbons are there, and from each carbon one hydrogen gone, and in its place 3 CHO group attached on all 3 carbon. Then first carbon 2 hydrogen will remain, in the middle carbon 1 hydrogen will remain, and in the last carbon 2 hydrogen will remain. Then now what will be the nomenclature? Then here you have to write propane. Propane you have to write, and then you have to write, because carbon number 1 aldehyde group is there, carbon number 2 also aldehyde is there, carbon number 3 also aldehyde is there. Hence you should write propane, propane 1, 2, 3, propane 1, 2, 3, tricarbaldehyde, carb, here also you can use the word carb, propane 1, 2, 3, tricarbaldehyde. Okay, here important point you should note down that to give identical treatment to all aldehyde group, the compound is named as what I have told you, because all three carbons are identical. They to give identical treatment means here also 3 carbon with 3 carbon, 3 groups are attached, just like in benzene ring. In benzene ring, alternate double and single bond is there. Alternate double and single bond is there. Then maximum possibilities for 3 group can be attached, and further it can be repeated in the other side. Then here, why it is used carb word here, 1, 2, propane 1, 2, 3 carbaldehyde, then their reasoning I am telling you, to give identical treatment. To give identical treatment to all aldehyde group, the compound is named as propane 1, 2, 3 tricarbaldehyde. Okay. Now I am stopping only here. Next class again I will continue. Thank you.